Okay, so solving equations, learning target number 1. One-step equations. Okay, so if you didn't do this, you better be doing it with me now, because these, just like this, will be on your little mini quiz on Tuesday. Okay, so, and that quiz does count as a grade. First thing we always do when we're solving equations is what? Draw a line separating the left side of the equal sign from the right side. Then, what question do we ask? What question do we ask ourselves every time? Owen? What is happening to the variable? Now I'm going to ask you. What is happening to the variable? Natalie? By? It's being multiplied by 18. So how do I undo multiplying by 18? You're going to divide by 18. Okay. What does that leave me on the left side with? X. What's it leave me with on the right? 2. Now, am I done? Shouldn't I just go up and substitute it or plug it back in? Is 18 times 2 36? Yes. Should there be anybody missing these ever? No, because... But the only way you're going to miss it really is if you just do the wrong process and you don't check. Here, we're going to draw the line. Now, what question do we ask here? Yep. What is happening to the variable? So what is happening to the variable, Sam? Or 4 is being added to it, however you want to say it. Okay, so how do I undo adding 4? Anna? Subtract 4, right? And then, of course, what you do to one side, you must do to the other. I'm left with P, and that's going to equal 8. Take it and plug it in. Is 8 plus 4 going to give me 12?
Yes.
Checked. Got it correct. But that's the process I would need to see. Here we go. What's the question we would ask here, Caden?
What is the variable, or what is happening to the variable?
What is happening to the variable? Well, so what is happening to the variable here? Yep.
It's being subtracted by 8.
Or you could say it as 8 is being taken from it. So if 8 is being taken from y, how can I undo that, Crystal? I'm going to add 8 to both sides. I'm going to get y equals 26. I'm going to take it and plug it in. Is 26 minus 8 18? Yes, it is. Okay. Here, what's the question that we ask? Yep. What is happening to the variable? So now I ask you, Danielle, what is happening to the variable?
You're dividing by 8.
I'm dividing it by 8. So how do I undo dividing by 8? I'm going to multiply it by 8 to both sides. I'm left with just m on the left, and I'm going to equal 40 on the right. Plug it in. Is 40 divided by 8 going to be 5, guys?
Yes.
Checked. Okay, now this next one here I'm going to take a little bit slower, because this is where I think the biggest struggle happens, is when fractions become involved. Okay? First of all, we're going to draw a line. Now, what are we going to ask? Ashley? What is happening to the variable? So, I ask you that. What is happening to the variable?
It's getting multiplied by 2/5.
It's being multiplied by 2/5. I've seen a lot of people working with people this morning in second period that are looking at this going, but wait a minute, Mr. Garrison, you said that was a division problem. It is. All fractions are division problems, but it's not about what's happening inside the fraction. It's about what is happening to what? The variable. And the variable is being multiplied by the fraction 2/5. So, how do I undo multiplying by 2/5?
You divide by 2.
I'm going to divide by 2/5. And I'm going to divide this by 2/5. Now I'm going to put it up to the right of it. Everybody knows why I did that, right? Isn't that how we did our algorithm of division of fractions? Now, just so you know, on this test there will be no calculators used. Okay, I don't think you need them. I'm not going to use crazy hard numbers, but you can't use calculators. I would need to see the algorithm for division. So, I guess you don't have to write it up there, but if you write it right there, whoops, sorry. If you write it below it, you're probably going to have to go over here and do the, the algorithm as you learned it, right? Which we know that division is just multiplication by the divisor's reciprocal. So that's going to be 5 over 2, and I'm going to end up getting 15 over 8. Top times top, bottom times bottom. So, or obviously you can turn it to a mixed number, but I'm going to leave it there. So that means that x equals 15/8. Now, can you still check it even though it's a mixed or an improper fraction? Sure. You know that it's being multiplied by 2/5, so I'm going to take 2/5, multiply by 15 over 8. I'm going to get 30 over 40. What is the greatest common factor of 30 and 40? 10. You divide the top and the bottom by 10. Does it get you back to 3/4, guys? Yes, it does. So it's all about what is happening to the variable. This one I'm not going to do, but it'd be the same thing. What is happening to the variable? It's being multiplied by 9 and 2/10. So I'm going to divide by 9 and 2/10 to both sides. Okay? And whatever that answer is, I think it's actually 3. Yeah, it is. D equals 3. Plug it in. Make sure it does give you 27 and 6/10, and it does. Everybody got that? Okay. Now let's go to the front. So that's learning target number 1. Remember, you have this video, but you also have the actual first one we did last week, okay, that you can watch as well. So both of them are available if you want extra practice. Remember, watching it isn't enough. You may need to stop, pause, practice, check. That's the way to go about it. Okay, so now we're on to learning target number 2 and 3. Learning target 2, that is where you're going to take an inequality, such as x less than 4, and you're going to graph it. Okay? Now, remember something. If I gave you the equation 2x equals 10, how many solutions are there for x? Yeah? 11?
Oh, wait.
No, listen, guys, you're not answering the right question. How many different answers could I put in there for x? How many solutions are there for that equation? There is one answer, because there is only one thing that's equal to 10. And in that case, it's 5, right, guys? Only 2 times 5 will give me 10, exactly 10. Inequalities, on the other hand, they can have an infinite amount of answers, right? That's the key thing. Inequalities have, the word infinite means too many to count, or just, the biggest number you can think of is infinity, right? Even though it's technically not even a real number. But it's just, we have to get a starting point and an end point, or numbers could go on and on forever, right? So, what this is saying right here is it's saying how many solutions, what could be my possible solutions for x here? Okay? Could 3 be a solution, guys? Yes. Could 2? Could 1? Could 0? Could negative 1.9843561? Yes. So, could I really list every single solution for this inequality? Could I? I could list every solution? Never. Never, 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 never. Think about it. It goes on forever. Okay, so I know that, let's say like 3.9, that's a solution, right? What about 3.09? What about 3.009? What about 3.0009? Can't this go on forever? I could never write every solution. The numbers just get too massive. They could go on forever. It's impossible to write every number. Impossible. Because it could go on forever. Everybody understand that? In other words, there's no other way. There's no way to write and to get infinity. Does that make sense? There is no infinity. It's just a number we give that means all the way to one end of the number line to the other end. Negative infinity. Okay? Huh? Negative infinity. You can go to infinity both ways. Right? Okay. Now, I know for a fact that there's individuals in this room that still do not know what these 4 inequality symbols mean, what the word is. So you may want to write this. You're going to have to study them, or else you will get them wrong. This is kind of like last chapter, guys. I can give you little tricky ways to kind of remember it, but unless you go home and just memorize it, I hate using that word, but that's honestly what it is, you're never going to be able to do this stuff. Okay? This one here is called less than. Whenever you see that symbol, it means less than. Okay? The way that a lot of students remember it is it kind of looks like a little L. Right? See it? Looks like an L kind of. Okay, so you can remember it that way. Okay? This one, I know, would then be greater than. Okay, and if you're not writing these, you're basically telling me that you know them, which is fine. But just understand, I'm not going to have much compassion come Tuesday when we get to this. The next one, this is probably the newest one for you guys, but you can still see it's just a less than symbol, or the top symbol is. We just add on one part, and it's or equal to. Okay, and then this one's going to be greater than or equal to. Everybody got that? That's the symbols. You must know that. If you don't know those, that is a problem. You will not have success in this chapter unless you know them. It's just that simple. You have to know them. 4 words or 4 symbols. Okay? And really, they shouldn't be that hard. You can see why they put that line there, because it's kind of like saying like an equal sign looks like that, right? So what they do is they say, we'll leave the bottom one and we'll just leave it as a less than sign, so it's less than or equal to. It can be either one. So this one up here is saying that all solutions have to be less than 4. So is the number 4 less than 4, guys? No, it is not. So would 4 be a solution here? Would 3.9 be?
Yes.
Would 0 be?
Yes.
Would negative 2 be?
Yes.
Okay, all those would be. So wouldn't it be too difficult to list out every solution? That's why we put it in a graph form, okay, which we'll talk about here in a little bit. Okay, so first of all, these are very basic, these first ones. Okay, G is less than or equal to, so you just got to know what that means. It's just like reading it left to right. G looks like an L, or equal to 55. Here's what I would like you guys to add to your paper, though. Could this also be written as 55 greater than or equal to G? Yes, it absolutely could, guys. You need to get in the habit of not always seeing the variable on the left side of the inequality. It can be on either side. Just like if I wrote 2 equals x, isn't that the same as x equals 2, guys? Same exact thing. It doesn't matter. You're just saying they're equal to each other. But I want you guys to all look at this. Is the inequality symbol still the side with the T? Is it still trying to eat the 55 in my other problem? So is this reading the same way? You can read inequalities from left to right or right to left. If I were reading this, I would say G less than or equal to 55, right? Could I read this way and read it as 55 greater than or equal to G? Absolutely, which is why I put it there. So I want you guys to understand that, because the variable won't always be on the left. Here we have Q, greater than or equal to again. So we know it's greater than, meaning it's trying to eat the Q, or equal to 28. Or you could write it as 28 less than or equal to Q. Again, it's trying to eat the Q. I just said write this. It's trying to eat the Q regardless. The bigger part, the greater part, still trying to, it's facing the Q. Here we go. P is greater than 15. Be like that. Well, if P is greater than 15, doesn't that mean that 15 is less than P, guys? See how that works? You need to get to understand this. You got to understand that. Here, y less than 20. Okay, y less than 20. Okay, well, if y solutions are less than 20, doesn't that mean that 20 must be greater than y? Hard to think about, but if you ever flip your 2 sides of the inequality, you must flip the inequality symbol as well. Everybody understand that? Okay, let's practice graphing now. Okay, first thing I want to add up here to this, if you were writing this up here, we got to know what kind of dot we're going to use. So we're going to use an open dot for just less than. We're going to use an open dot for greater than. We're going to use a closed dot for less than or equal to. We're going to use a closed dot for greater than or equal to. Now I want you to think about something real quick. Let's say I took number 5 here, and I took it and wrote, actually I don't want to use 5. I want to use number 6. You don't have to write this, just watch. If I wrote this as y equals 6, you would graph it with 6, and then you'd put a dot above 6, right? Just like that? Because y equals 6, but you wouldn't shade, because it's just y equals 6, right? So when we shade, that's all about where the solutions are. Are they bigger or smaller? The closed dot is saying that whatever the dot's over top of, it's including that as a solution. Okay? So Now, I didn't say this in the first video, but I want to show you it now, and I think you guys are going to think this is very easy, so please watch. Whenever you're graphing an inequality, there are 3 numbers, only 3, that you need to show on your number line. I said it differently in the video because it was last year's. So listen, 3 numbers. I think you're going to appreciate this. These are the 3 numbers. You have to show whatever the number is that is given. So we're going to show that. You got to show 0. You got to show that number. And then what other number do you think we need to show? Negative 12. It's opposite. So just remember that. Whatever the number is, whatever W is greater or equal to, or less than or equal to, whatever that number is, that number and its opposite, as well as 0 on there. Okay? Now, what is this saying? Somebody tell me what this is saying right here. Yes?
If W is less than 12.
So that means solutions that make this true must be less than 12. So the first thing, what kind of dot am I going to use? What kind of dot, Crystal? No? What kind of dot am I going to use? I'm going to use an open dot. Now, I want to know where the solutions are that would make this true. What could W be that would make it true? Are those solutions to the left of 12 or to the right of 12? Sam? To the left, absolutely. And is there a way to check this also? Hello? Absolutely. If you're saying that everything from here all the way shaded all the way to a negative infinity is what it's saying, right? All the way forever, all the way. Doesn't matter how far you go. Anything that's in the shaded region is going to make this a true statement. So can I just pick a number that's in this shaded region and check it? So what I mean by that is I see that 0. Is that in the shaded region, guys? So I'm going to take 0 and I'm going to plug it in here. So let me zoom in a little bit so you can see it. I'm going to rewrite it. Is 0 less than 12, guys? So it has to be correct. Now, isn't that a better method of being able to represent all solutions less than 12 than trying to write them out? Yes. You can't write them out. It's impossible to write every number. So we do it like that, okay? So here we go. Y greater than or equal to 6. Okay, so what 3 numbers need to be on there then? I need to put 0, I need to put 6, and I need to put negative 6. Very easy to do it that way, right? Now, is this going to be a closed or an open dot here? Absolutely closed because we're including 6. Does 6 make this a true statement, guys? It doesn't. Is 6 greater than or equal to 6? Yeah, it's one or the other. It's either greater than or it's equal to, and it's equal to. So, where are my solutions for y? Are they to the right of 6 or are they to the left of 6? They are absolutely to the right. Now, let's check. Give me a number that would be to the right of 6. 7, sure. 7 would be over here somewhere, right? So I plug in 7. Is that a true statement? Is 7 greater than or equal to 6? Absolutely. Okay. Next one. Here we got z less than or equal to 10. Okay. I need to plot 0. I need to plot 10. And I need to plot what? Now, is this going to be a closed or an open dot? Oh, closed dot, absolutely. Now, is this little inequality asking for all the values that are to the left of 10, or is it asking for all the values that are to the right of 10? What would make this true? Caden? You guys see that? Do we all get that? Okay. Now, can I check it? What number do I see that's in that shaded region? Could I also pick 9 or 8 or 7 or 6 or 5? Absolutely. Sure. Doesn't matter. I'm just going to pick 0. Is that a true statement, guys? Then I must have shaded the right way. Now, I want to make sure you understand this. Some of you will get in this really, really bad habit of just looking at the direction of the inequality. And you'll say, well, that kind of looks like an arrow. And whenever it's the less than symbol, it's always shading to the left. And whenever it's this, it's always shading to the right. Whoops. Do you guys see that? That only works when the variable is on the left. I want you guys to understand this. If I gave it to you like this, then technically if you're using that method, you would shade to the right. But it's all about reading it. We're wanting to know these solutions, all the things that z could be, are less than or equal to 10. Okay? Let's go to the, well, it's just down on yours. Next page on mine. Okay, these. Okay? Now this one, it told you what variable to use. Otherwise, I would not care what variable you used. So I'm going to use A. Okay? I see the dots over top of 14. So I just get it laid out like that, first of all. A and 14, that's my variable and that's my number. Now, you see that that's an open dot. So what does that mean? It's either which inequality or which two is it going to be? Yeah. It's either one of these. So, what is it saying? Is it saying that the solutions are bigger than 14, or is it saying less than 14? So it's got to be greater than. But make sure you write this one also. 14. Notice the mouth is trying to eat the variable, so it's got to remain eating the variable. Are those the exact same inequality, guys? Actually, I just said write something. Come on. Okay, here we go. A and 11. Okay. The two inequalities could be what or what now? It could be less than or equal to, or greater than or equal to. So what's it showing? Where's it shaded? Is it showing the solutions greater than or equal to A or 11? Or is it showing the solutions less than or equal to 11? Sure, it's showing these solutions. And again, just grab a number and plug it in. Is 16 greater than or equal to 11? Absolutely. So let's write it the other way now. 11 less than or equal to A. Yes?
Do you always have to write it?
No, you don't. But I want you guys to everybody gets in a bad habit of always seeing it like this. And then if you get something like this, like on your review sheet this week, there's one like this, it kind of throws you. Because you get in the habit of saying that less greater than or equal to 11. That means any value that is greater than or equal to 11 could make this a true statement. So that could be 11.1, 12.3, 15.649, doesn't matter. Okay, next one. Here we got A, and we got 14. It's an open dot, so I know it's either going to be less than or greater than, only now it's shading to the left. So that means less than 14. And finally, we have A and 15, because the dot's over top of 15 right there. Now I know it's going to be an or equal to, right? Because it's a closed dot. So now is it showing the values that are less than or equal to 15 or greater than or equal to 15? Less than, right? Okay. Okay, now we just get into a little bit of decimals and things like that. Really doesn't change anything. I'll do these real quick. Okay, we still just put 0. We put the value, 4.5, and we put its opposite, negative 4.5. Okay, it's pretty easy. I know it's going to be an open dot over 4.5. Now, what's it saying? Is it want solutions that are greater than 4.5 or less than 4.5? Greater than. So, give me a number that would be in that shaded region. Crystal? 5. Is 5 greater than 4.5, guys? Yep, we checked it. We're all good. Okay. This is going to be 0. This is going to be 10.5 and negative 10.5. It's going to be an open dot over 10.5. But now we want solutions that are, yes, less than, so those would be to the left. Plug in 0. Is 0 less than 10.5, guys? Yes, it is. Here we got 5 3/4. And we got negative 5 3/4. Didn't that make it easier, guys, than trying to count by fourths or something like that? Just do it like that. Now I see that it's a or equal to, so that means it's a closed dot. Now it's wanting to know where the solutions are, smaller or bigger than 5 3/4. Smaller. Okay, plug in 0. And is 0 less than or equal to 5 3/4? Good. Here we got 0 and we got 9/10. We got negative 9/10. Okay. I know it's going to be a closed dot on 9/10, but it's wanting to know where the numbers are which way, to the right or the left? To the right. Give me a number that's to the right. Yep. To the right. 10 tenths, which is 1. 1 whole, right? Which would be, is 1 greater than 9 tenths? Absolutely. So we checked. Okay? Go up to the top. Now these ones, guys, this is the ones I really wanted to focus on here for a minute. These are the ones, as you can see, the variables on the right, correct? That makes it a little weird. Do you have to leave it that way? Do you have to leave it that way? No, matter of fact, I never do. Even as a 6th grade math teacher, if I was giving that inequality right there, if somebody said, Mr. Garrison, can you graph that? The first thing I would do is I would rewrite it. So if you didn't do that, please do it now. Because it's just going to make your life easier. There's nothing, it doesn't change. Still, the inequality is trying to eat the 9. So it's still saying that 9 is bigger than m, regardless of how it's written. Or you could say it opposite that. M is smaller than 9 or less than 9. Okay? So now let's graph it. So I'm going to put 0. I'm going to put 9. And I'm going to put negative 9. Is this going to be a closed or an open dot? Everybody? Open dot. And since we're talking about, since 9 is bigger than all the solutions, or you could say it as all the solutions are smaller than 9, we're going to be shading to the left. Okay? Pick a number. Plug it in. Is 9 greater than 0? Is 0 less than 9? Either way it works. This one, just rewrite it. It's trying to eat the negative 15. Leave it trying to eat the negative 15. So I put 0, I put negative 15, and I put 15. Is this going to be a closed or an open dot, everybody? Closed over negative 15. Okay, so now we're trying to figure out where my solutions would be. Where would solutions be less than negative 15? Hello? To the right or the left? To the left. Now let's say you accidentally put to the right. This is wrong, but let's just say you did that. Then you check it. You say, okay, I'm going to plug in 0. And then ask yourself, is 0 less than or equal to negative 15? No, a zero can't be less than a negative, right? So then you'd catch yourself and say, oh, duh. It's the values that are smaller than negative 15. Now we'll take one of those. Negative 20. Is negative 20 smaller than negative 15? Yes, it is. Okay, last two. Here we got 0. Here we got 3.5. And here we got negative 3.5. Is this going to be a closed or an open dot? And are we talking, oh, I should probably rewrite it, right? Just to make my life easier. It's still trying to eat the t one way or another. Everybody understand that? What I'm doing there? Just flipping it over top of the inequality symbol and also flipping the inequality. Now we want to know where the values for t, the solutions, are greater than or equal to negative 3.5. That would be to the right. I'm going to plug in 0 because that's the easiest one. When I plug in 0, what do I get? Is 0 less than, or is 0 greater than negative 3.5? Yes, it is. And finally, I have 0, and I have 3.5, and I have negative 3.5. Is this going to be a closed or an open dot? Open on 3.5. I should rewrite this. C is going to be greater than 3.5. Aren't those the exact same inequality, guys? Same thing, trying to eat the C. Either way you look at it, it's saying 3.5 is smaller than the solutions for C. Or you could say it the opposite way, which is your solutions for C are greater than 3.5. So that means I'd be shading this way. Give me a number that's in that shaded area. I'm at 4. Good. Is 4 greater than 3.5, guys? We checked and we made sure. Okay?